Starting Unit 2, Part 1, we're going to look at solving equations. And this video is going to take in about 3 or 4 learning targets, just giving you an overview of solving equations. And then in class we can go a little more in depth with our examples and our concepts. Now, something to think about with solving equations, we're talking about properties of equality. And these properties are very simple. They all have one basic purpose. And you all know how to finish this statement. What you do to one side of an equation, you do to the other. And you all have learned that before. It creates an equivalent equation. Okay, I've got this all caps here. That's all we're doing with equations. When we solve for x, basically we're just creating an equivalent equation because it's still an equation. It's in x, it's solved for x. And no matter what you do, I could give you any equation, and as long as you do the same thing to both sides, and when I talk about both sides, when we talk about the side of an equation, we're talking about on either side of that equal sign. What you do to one side of the equal sign, you do to the other side of the equal sign. As long as you do that, you can do anything you want to an equation and still have an equivalent equation left over. Now, there are 4 properties, and we're just going to go through these quickly. Addition, you add the same number to both sides. Subtraction property of equality, you subtract the same number from both sides. Multiplication, you obviously multiply both sides by the same number. And division, you divide both sides by the same number. So these are the 4 different properties of equality we will use in order to move values from one side of an equation or one side of the equal sign to the other. Now, we're going to look at one thing. We're going to talk about a vocabulary term that you may or may not know. It's called isolating, or to isolate the variable. If you isolate someone, that person is left all by themselves. So that's what we want to do. We want to isolate the variable. We want to move everything away from the variable and leave it all by itself. Now, one way to do that is to use inverse operation. To undo the problem. Using inverse operation. Inverse means the opposite. So think, what is the opposite of what's actually being done to the problem? That's what you're going to do. So this is what I want you to think about. I'm going to draw myself a little person here. And they're going to think. This is their thought cloud. Whenever you come across an equation, this is what I want you to think about. What order should I go in? What order should I go in to simplify the expression? So think about this. If you were given an expression, which we've already dealt with these for an entire week now, what order were we using? Well, we were using order of operation. So what order should I go in? I want you to actually out loud say the equation, and that's the order that you would actually solve that problem. Like if I gave you a value for the variable, that's how you would simplify it. But for you, since you think about what order you should go in for the expression to solve, work backwards. Really, that's all you're doing with equations, is working backwards. Think about what should you do if you were going to simplify the expression. Think order of operations. But then work backwards. That's how you solve the equation. Okay, so this is kind of your little thought bubble here. All right, so let's look at some one-step equations. Let's just start off really simple with one-step equations. A couple of examples, 2 or 3 examples here. If I give you, for example 1, if I give you 15 plus s equals 42, I would want you to think, what order should you go in to simplify the expression? Well, you would take s and add 15 to it. That's what you would do. Or 15 plus s. This is a positive 15 because that's understood since there's not a sign there. So if I'm adding that 15, that positive 15 to s, I've got to work backwards. So what's the inverse of a positive 15? The inverse is a negative 15, which positives and negatives you're going to learn. You need to get this in your head now. Positives and negatives are also addition and subtraction. It's the exact same sign. It just depends on how you read it. If I ask you what kind of s this is, you would tell me it's a positive s because of that sign in front. But if I'm reading this equation, you would read that as 15 plus s. Okay, same thing here. This is a negative 15, but if I read this vertically, this is 15 minus 15. Okay, so negatives, subtractions means they're the same sign. It just depends on how you are actually speaking the problem. So 15 minus 15, this gives us 0. So we have isolated the s by itself. And now all we have to do is 42 minus 15. Okay, and you should be able to do that in your calculator and get 42 minus 15. Now, moving on to example 2. Example 2, we're going to look at another one-step equation. You should have this filled in. 2x equals 3/5, that fraction. All right, well, think about what is this operation. If a number and a variable are side by side, this indicates multiplication. So when I'm thinking about how would I simplify this, if I were going to simplify, this would be multiplying here. So if I'm going to work backwards, what's the inverse of multiplication? And that's division. And you all should know that the fraction bar also means division. And notice that if I split this down the middle, some people do this. I divided this side by 2, so I have to divide this side by 2. That's my property of equality. So 2 divided by 2 gives me 1. So that's how I isolate my x. And then all you have to do, and some of you all have done this upside down in the past, be very careful. Take 3/5, divide it by 2 in your calculator, 3/5 divided by 2, and that will give you your answer here for x. Make sure you do not divide upside down. Start top to bottom, 3/5 divided by 2. All right, so very simple. Couple of one-step equations there. All right, let's look at some two-step equations. Again, we are just simply, it's the exact same thought process, thinking backwards. So if I give you for two-step equations, let's look at example 1 under two-step. 2x plus 11 equals 51. 2x plus 11 equals 51. All right, so I just read that out loud, but I want you to do that. This is the thought process that I go through and that I want you to get in that habit of. If I were going to simplify, I would take x, multiply it by 2. I would do 2 times x first. Then I would add 11. Order of operations, I would multiply, then I would add 11. So I've got to work backwards from that. Multiplication was first, then addition. Not only am I working backwards, but remember it's the inverse, okay? So if the last thing that I was going to do to this problem was to add 11, then the first thing I have to do to solve it is to subtract 11. You do the inverse, work backwards. Now again, if having this line down the middle here of your equal sign helps you to keep the two sides separated, that's great. So subtract 11 from the left of that equal sign. I have to subtract 11 from the right. Now think to yourself, why am I moving the 11? Why not move the 51? I mean, I could move the 51 maybe, but why am I moving the 11? Because we are isolating the variable. The 51 is not bothering the variable. Okay, the 2 and the 11 are, so that's why we're moving it. All right, so if I subtract 11 from this side, I'm left with 2x, because this gives us our 0. And that equals 51 minus 11, which is 40. But I still am not finished because I haven't isolated. This is two-step. That's just the first step. The second step that I have to do is, the first thing I was going to do here is multiply, so the last thing I'm going to do, the inverse of multiplication, is division. So this looks a lot like that one-step problem we just did. So 2 divided by 2 is 1. So x equals, and then all you have to do is take 40, divide it by 2 to get your answer. Alright, so that was a pretty simple one. I want to look at example 2. Let's look at one more. 10 equals x over 4 then minus 8. And that's actually how I would want you to read that. I want you to think about this. If you were going to simplify this, if I gave you something to plug in for x, you would take x, divide it by 4, then subtract 8, because 8's not there, it's not on the top of that fraction, it's actually after the fraction. So x divided by 4, then minus 8. So division, then subtraction. So if I'm going to go backwards, the opposite of subtraction would be addition. So I'm going to have to move the 8. Now notice this equation is backwards. So I'm actually working on the right hand side, moving stuff over to the left. 10 plus 8 gives us 18 equals negative 8, positive 8. If you type in negative 8 plus 8 in your calculator, that gives you your 0. So then you're just left with x divided by 4. And let's think about this. What is the inverse of division? The inverse is multiplication. So that means I'm going to multiply this entire side by 4. So I have to multiply this side by 4. So if multiplication is the inverse of division, then that means I have eliminated that 4. It actually becomes 1. This is like saying 1/4 times 4. That'll give you 1. So I'm left with my x, and then once I multiply 4 and 18, I will have my value for x. Again, I've solved the equation for x, but it is still just an equivalent equation. Alright, so let's look at one more, multi-step equations. Multi-step equations, the only difference in those is that it may involve some simplifying. So you may have to do some simplifying first before you can go into isolating the variable. Okay, so let's look at, this is easier maybe to explain if you look at an example. Example 1, we've got 8x plus 5 minus 6x equals 25. Now I'm going to use this dotted line again down the center because I'm going to look at this. I have two sides to my equation, and one side actually has x's in two different places. So when I talk about that you may have to simplify first, this is what I'm talking about. I have an 8x and a negative 6x. Remember I told you that's negative or subtraction depending on how you read it. And they're both on the same side. So it would just be like if I had 8 minus 6 on one side of an equation. I could go ahead and simplify those. These are called like terms. 8x, negative 6x. I have like terms. They both have x's. The coefficient of those x's are different. That's okay. Those are actually the ones that we're going to add or subtract. In this case, we're going to subtract them. I have 8 x's, and I'm going to subtract 6 x's. So 8 minus 6 is 2, so I have 2 x's left over. Still have that plus 5 equals 25. So notice that for this multi-step equation, I just had to simplify those x's first. And now I'm actually down to a two-step equation. Multiply by 2, then add 5. So inverse operation, subtract 5 from both sides of your equal sign. So that leaves us with 2x equals 20. And then the opposite or inverse of multiplying, we've done this 2-3 times now, is to divide by 2. So 2 divided by 2 is 1. So I've isolated the x, and once you divide 20 by 2, you've got your answer. Now there's a lot more to two-step and multi-step equations in the examples we have here, but we'll get into more in-depth problems with multi-step and two-step in class.